So we're going to multiply the left by a sine theta over a sine theta. And we'll multiply the right-hand piece there by a 1 plus cosine theta over a 1 plus cosine theta.
Do you have to distribute if you do 1 plus cosine theta times 1 plus cosine?
No, I wouldn't do that.
You just keep it separate?
Yeah, keep it separate, yeah. So what does that give you on the left-hand side there? What do you get? Sine squared theta plus, this is 1 plus cosine theta, all squared, all divided by the common denominator of 1 plus cosine theta times sine theta.
Sine squared theta?
No.
2 sine equals, and then 2, it's cosecant, right? Equals 2 cosecant. Is that what the original one is? Yes. Alright, let me see. Kimia, you got me started on that. Thank you.
What?
Yeah,
With the
like,
whole,
can you convert?
sine squared plus cosine
Wait, Mr.
squared
Joe.
is 1.
Yeah.
Alright, let me see.
So 1 plus 1 plus 2 cosine theta. 1 plus cosine theta. Sine theta. That gives us 2 plus 2 cosine theta over 1 plus cosine theta times sine theta, which is 2 times 1 plus cosine theta all over 1 plus cosine theta sine theta. Cancels out, leaving us with 2 times 1 over sine theta, which is 2 times cosecant theta, which is what we had. One down. And we're going to do this one in our notes because then I'm going to have you guys try one that's very similar with the new strategy on your own. Okay, so right off the bat, left side or right side, they look pretty equal. So that automatically puts it in the green circle category, right? Not knowing which side is obvious one to pick. Yep. And here's the strategy, right? So the strategy for this one is, do you notice how these have two different denominators, right? And there's really nothing that they have in common. So what you gotta do is pick a side, all right? And multiply that side by a fancy 1. And the fancy 1 should consist of the denominator of the other one. So here's what I mean by that. So I'm going to pick the left side, all right? And I'm going to multiply by a fancy 1. And the fancy one that I'm going to choose is the denominator of the other side. So that would be what, everybody? Sine theta over sine theta, right? That is an interesting tactic. Okay, so after all, we're allowed to multiply by 1s however we want.
But only on one side.
But only on one side, yeah. So this is going to give us sine theta, right? Or sorry, sine squared theta all over sine theta times 1 plus cosine theta. Is everybody cool with that part so far? Okay. Now, let's use a trig identity. Can we change sine squared into something?
1 minus cosine.
Very good. So this becomes 1 minus cosine squared theta all over sine theta times 1 plus cosine theta. Okay, so is everybody cool to this part here? I just keep moving it up so you can see. Now, do you have to recognize the difference of two squares? Do you remember what this factors to? A squared minus b squared? What does that factor to?
A plus B.
Yes, very good. A plus b times an a minus b. That's our old Algebra 1 trick. Does anyone see a difference of squares here? Yeah, on the top, right? That says 1 squared minus cosine squared. So the 1 is acting like the a, and the cosine is acting like the b. So that's going to become 1 minus cosine theta times a 1 plus cosine theta. All divided by sine theta times a 1 plus cosine theta. You guys cool? Now you can cancel, right? You can only cancel multiplication, guys and girls. So therefore, that cancels. Leave me with 1 minus cosine theta all over sine theta, which is exactly the thing that we were looking for way up here. And when I pinch it down, there you go, you can see. Okay, so try this one at your table groups. Talk to each other, help each other out, communicate with each other, encourage one another.
Messenger.
Yep.
You don't do any like extra code or anything, right?
So,
Or is it 1 point?
a point. One minus sine theta all over cosine theta, which is what we had to get. So that says the tangent of theta minus the sine of negative theta over 1 plus cosine theta equals tangent theta. I want you to try and establish the identity and then